Hello everyone, in today's video we will be discussing about the designing of the well screen that is being provided inside the aquifer. If you want to just extract the water, not only the water, but if you want to just have water at a proper discharge, along with that it is also required that along with the water the dust particles, the gravel, that doesn't come inside of the well. So in order to achieve all such kind of the characteristic, the designing of the well screen is required such that they have proper slots openings which restricts the critical velocity of the water, as well as permits the entry of any clay particles, gravels inside the well. So we need to just go in the designing procedure of the well screen. Okay, so in order to do so, what we actually do, we just basically try to do a analysis of an aquifer, and based upon that analysis of the aquifer we basically obtained a grain distribution curve for the aquifer, which actually help us understand what is the actual distribution of the grain sizes if you go deep inside any given aquifer. Okay, so depending upon that, depending upon this analysis, we actually need to obtain these three things from this grain distribution curve of the aquifer. First is D10, next is coefficient of uniformity, and then we have D50 of the aquifer. I think all of you quite be aware of what is D10 and D50. These are the size of the particles when 10% of the fines are allowed to pass and rest 90% are retained. Similarly, it is true for the D50 also. Okay, and we have coefficient of uniformity, which is equals to the ratio of D60 over D10. Okay, so these are some of the fundamentals that we go through, and depending upon the actual values of coefficient of uniformity, let's say suppose if its value is less than 2, or then we will say that it is classified under uniform. And let's say if we have evenly grained sand, okay, then its value will be between 2 to 3. So depending upon, or just by looking at the values of the CU from our graphical analysis, we can say that what is the basically type of the soil, whether it is a grained soil, whether it is clay soil, or whether it is uniform soil or ununiform soil. So depending upon just the values, we can just predict the what type of soil will be there, and depending upon that we will provide the size of the opening in order to restrict the entry of the particles into the bore wells. So there must be a proper size of the slot openings of the screen. So whatever the slots through which the water will enter inside the bore well, so that must be given a proper size. Okay, and that size should be such that it is not too small and neither it is too big. If it is too small, then that will permit the entry of the water, and if it is too large, then it will, apart from the entry of the water, it will also permit the entry of the fine particles, gravel. So that we won't want in if we are designing the size of the slot opening. So therefore certain consideration must be considered if we want to just go for the designing of the size of the slot. So depending upon that slot size, between 1.6 to 3.2 mm is generally preferred in India. And if you see a wider view, then we have the minimum 0.2 mm and maximum 5 mm size is preferred. Okay, next we have the basic criteria for the selecting of the size of the slot opening for the non-gravel pack and the gravel pack well. If we are going for a non-gravel pack, okay, then what should be the slot opening, and if you are going for gravel pack, then what should be slot opening at that. So we will see one by one both of these cases. So let us first come in the slot opening for the non-gravel pack well. Okay, so if it is a non-gravel pack, then if we are just the well, okay, and if we are using a certain packaging material from at the sides of these wells, so that should be a non-gravel material. In that case, the opening slot, the optimum slot opening is kept at D60 means, at D60, it means that is the size of the particle when 60% are allowed to pass and rest 40% are retained, and that is a case for a non-corrosive case. And for a corrosive water we go for a D50. Okay, so that is the major criteria if you are just going for the opening for a non-gravel pack type of well. Similarly, if you are going for a gravel pack well, then the basic criteria changes here, and here we mainly go for a D10 type of sieve where the size of the particle is such that 10% are only allowed to pass and rest 90% are retained on the sides of the that is just retained by the gravel pack. So these are the basic two criteria which helps in governing what should be the slot opening. Okay, now the next terminology is the pack aquifer ratio, which is defined as the ratio of D50 of the gravel over the D50 of the aquifer, and depending upon what is P by A ratio, there are certain recommendations which have been made by the Central Board of Irrigation and Power, and which says that if its value is between 9 to 12.5, then we have Cu value less than equals to 2, and if it is between 12 to 15.5, then Cu values is 2. So just if we know what is the type of gravel and type of the aquifer, if we know what is the exact size, then we can just work on out on this P by A ratio, and depending upon that we can predict the Cu, and if we can predict the Cu, then we can easily say that it is a gravel soil or it is a clay soil, whether it is a uniform soil, whether it is graded soil or non-uniform soil. So just by looking at these values only. Next important thing is designing the length and the size of the screen. Okay, so what should be the appropriate length, that should also be considered if we are just designing the screen. So there is one simple principle that is based over here is such that the length of these screens should be such that whatever the area of the screen openings are there, they are quite adequate for a given discharge of the water through these fields. So these areas should not be so less that whatever the discharge that we want through these openings are too less, and it also should not be too more that we are getting an excess discharge which permits the entry of the fine particles. So the area of this screen opening for a per meter length of the screen, that varies between 15 to 20% of the screen area. Okay, and if we are going for a more opening, let's say greater than 20%, then we are compromising on the strength of the well screen. Obviously its strength will be decreased. Why? Because we are increasing the percentage of the holes in there. So these are the two basic criteria for the length of the screen. Again, there are certain recommendations according to the IS recommendation, what should be the optimum entrance velocity in the well through these holes, and depending upon that what is the coefficient of permeability of the aquifer. So if we know this K value, then we can just have a direct relation between these value, and let's say if we have 0.24 centimeter per second, then their optimum velocity will be 5 centimeter per second. Okay, so this table actually helps in just getting the optimum entrance velocity of the water inside the well. Similarly, there is other recommendation regarding the what should be the screen diameter in centimeter. Let's say if we want to have a 30 centimeter dia screen, then in that case we will be having a discharge of this much amount of liter per meter. So these are certain recommendations which we must follow, that guidelines have been given by the Indian standard. And again, we have a simple formula if we want to determine what should be the minimum length of the screen that should be given. So this formula we can use in order to determine that minimum length, and that is discharge over A naught into VE. So if we have these values from our previous data, we can just work out on the length of the screen. Okay, so till now we will keep this lesson till this point, and in the next tutorial video we will be discussing about the various types of the screen. Okay, thank you.